Hi all. In this lesson, you will learn about Android's architecture. Android stack is roughly divided into 5 sections and 4 main layers as shown below in the architecture diagram. They are the Linux kernel, the native layer which consists of libraries and the Android runtime, application framework layer, and the applications layer. Let's have a look at these layers in detail, and let's start off with the Linux kernel layer. So Linux kernel layer is found at the bottom of the Android stack, and it never really interacts with users or developers, but it forms the heart of the whole system. It basically provides system functionality like process management, memory management, device management such as camera, keypad, display, etc. Also, it handles things that Linux is really good at, such as networking and a vast array of device drivers. So basically Linux kernel layer has various drivers such as the display driver, camera driver, flash memory driver, binder, which is nothing but IPC, which means inter-process communication, keypad driver, Wi-Fi driver, audio drivers, and more. So Linux kernel layer is for basic system functionality. So as there are various Android versions which have been released, they have used various Linux kernel versions. For example, Android 2.2, which is nothing but Froyo, very common in entry-level smartphones, uses Linux kernel version 2.6.32. In the case of Ice Cream Sandwich, which is Android 4.0, it uses 3.01 Linux kernel version, and the latest Android KitKat uses the 3.4 Linux kernel version. The next layer is the native layer, which consists of libraries and the Android runtime. These libraries are based on C, C++. For example, OpenGL and SGL are for 2D and 3D graphics, SSL for internet security, WebKit for web browsers, SQLite for database management. libc is a well-known C library, and the native layer also consists of the Android runtime, which has core libraries and the Dalvik virtual machine. Core libraries are nothing but Java libraries. All the Android applications are written in Java. The Dalvik virtual machine is responsible for running these applications on your device. So let's have a look at the working of Dalvik Vm. So the advantage of using Dalvik Vm is it handles memory efficiently. The point that you need to note is Dalvik Vm enables every Android application to run its own process with its own instance of Dalvik virtual machine. So every application runs its own process with its own instance of Dalvik VM, and it is designed to run multiple VM instances at once. So Dalvik VM can run multiple instances at the same time. So this is basically a security feature whereby which every application is sandboxed in its own environment. So when two applications are running, it cannot connect between themselves. So that's the main idea. We'll talk about sandboxing and this feature in a later lesson. So if you compare Dalvik VM with a regular Java VM, there are certain differences. In a Java VM, Java source code is compiled to Java bytecode by Java compiler, and then it executes the Java bytecode in the Java VM, whereas in Dalvik VM, Java source code is compiled to Java bytecode by the Java compiler, which is then compiled to Dalvik bytecode by dxtool, and then finally gets executed in the Dalvik VM. So the next layer is the application framework layer. The application framework layer provides many higher level services to applications in the form of Java classes. Application developers are allowed to make use of these services. So you can get more information by just reading the PDF file that comes with this lesson. Basically this gives you This layer gives you many higher level services to applications. Basically, this is where developers actually work. The final layer is the application layer, and this is what the end user actually sees. So this is where you see the home, contacts, phone settings on your device. So in this lab session, we're going to show you how to check your Linux kernel version on an Android device using ADB as well as via phone using the GUI interface. So let me first start my emulator instance. So I'm going to navigate to the Android directory. By now you should know how to start your Android instance, emulator instance from your command line. So my emulator instance name is JSinfosec lab machine, so I'm just going to start that one. It's going to take a little time to load. Meanwhile, I'll open up another tab. So to check your kernel version via ADB, you need to first get a shell. So first check whether ADB is up. So let me first let me get a shell on my emulator. So to get your kernel version, you need to enter the following command: cat proc version, and this will give you the Linux kernel version that Android is using. So Android 4, the Android KitKat is using the Linux 3.4 kernel version. You can also get other information about CPU by doing a cat proc CPU info. This will give you information about the processor, vendor ID, and other stuff. So you can also check your kernel version directly from your device. You need to go to your menu, system settings, and then go to about phone, and then you can find out the kernel version that your Android instance is using. So Android 4.42 is nothing but KitKat uses 3.4 kernel version. So this is how we will go and check your kernel version. The next thing that I wanted to show you is how each Android application has its own process with its own instance in the Dalvik virtual machine. So if you compare this actually with the Linux world, every application runs under the current user. So for example, if there is an application running on this Linux machine, it has to run under either John or the root, which is the super user. So let's go and check that one. But in the case of the Android, every application has its own user ID. I'll just show you. So let me first open up a tab. So now we'll check up with the Linux world. So if I do a PS, I can see all the processes that are running. So you can see the bash process running. You can do a PSE to see all the process. So Kazam is actually the screen record software that I'm using. To get the ID, what you can do is, user ID, you can do an ID, and you can see the current ID. Current ID number is 1000 and user is John. As I said, there are two IDs, user and the root is always 0. So now to get information about the process, let's take Kazam for example. What you need to do is you need to first go to the proc folder, and if you do an ls, you can also see the process ID actually in the proc folder. So what I'm going to do is I'm going to say cat and then say status. Now you can see that the user ID is 1000, that is nothing but John. And if you take another application, let's take bash itself. So the process ID is 9702. and you can see the user ID is again 1000. So all the applications have the same user ID, whereas in the Android world it is every application has its own user ID. Let's go and check that one. So now I'm in the Android shell. So now let me first go to find out all the applications that are running on my Android instance. So if you do a PS, you can see all the stuff that are running on your instance. So these are applications that are running on my Android emulator. They usually start with AAP or something like this, UA0, A32. So these are applications U0, A20. So let's check these user IDs and see whether they are same or not. So let me um, check them. So the process ID for this app is 1546. So let me do a cat proc status proc. Sorry, I gave in the name. I need to give in the process ID, that is 1546. I've just navigated into the proc folder, so now should be okay. So now you can see that the user ID for this application is 132. Let's check for another application. Let's take this one, UAA6, which is 1491. So now if I do you can see that this uses a different user ID. So this uses 1006 and this application uses a user ID called 1032. So this is true, as we have mentioned in the PDF file. Every application has its own process. So the basic idea is to actually sandbox each and every application so that they cannot communicate between other applications. We'll talk about this in the security model lesson. So that's all for this video. If you have any questions or queries, please post them in the student forum or just send us an email to feedback@JSinfosec.com. If you're watching this course on Udemy, then please post the questions in the discussion section and we'll answer you. Thanks for watching.